Hello, 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 everybody. Welcome one, welcome all. Welcome to the World Quant Office Hours for Unit 1. Let me actually adjust this here. So, how is everybody doing? I am, as always, your friend and data science neighbor, Nicholas, and I am here to answer all of your questions about data science. Tell me, who is watching from Unit 1? I see Adebayo is here. Who else is here for Unit 1? Unit 1. I see Ken is here. Hello, Ken. Bon dia. Abadayo asks how I'm doing today. I'm doing great. The sun is finally coming out here in Southern California, and so I'm very happy about it. And I see Istvan has joined us. Jessica O'Reilly is here. Welcome, welcome. Glad you've all made it. George Adolfo M. I see everyone is here, and I see Ikenna is joining us from Nigeria. So welcome, welcome. Obianuju is also here. Welcome. Good to see you. Ola Di Meji is saying hellos. Well, hellos right back at you. I'm curious, how many continents do you think we have represented in the group today? Is anybody here from North America, Canada, United States, Mexico? What about South America? Anyone from South America? Anyone from Africa, Europe, Asia? Aquilo is saying hello from Porto. So Porto, Europe. We have Europe. We might not have Antarctica. M is absolutely right, but that's okay. Ken is here from Latin America. Jessica's here from the USA. We've got Africa. We've got Europe. We've got South Africa in the house. Hungary. Fantastic. Yemen. Wow, we have someone tuning in from Yemen. Hello. Salam alaikum. Kif el hal? And Adebayo is Nigerian, but joining us from Canada. Well, good. I hope you're staying warm in Canada. Wow, this is great. We have someone from Portugal and we have someone from Brazil. So we have, and I think we have people in this course from Angola as well. So we have a huge amount of Portuguese speakers. That's really exciting. And then anyone from Asia? Anyone from Southeast Asia, maybe? India? Not yet. It looks like, though, we have a lot of great people representing their countries. And of course, we're all being brought together here on one mission, and that mission is to learn data science. So, oh, here we go. Jessica is living in Taiwan right now. Excellent. So, we're going to give you the Taiwanese salute here. So, we have a Nigerian in Canada and an American in Taiwan. So, this is fantastic. Welcome, welcome. It's a very global group. Okay, so what sort of questions are people interested in looking at today? What can we help with? What can I help with? What can we as a group do together? I see Amen has just joined us. Hello, Amen. Hope you're doing well. Hope those university exams are going well. Wallace is joining us from Africa. Hello, hello. Abose is interested in memoization. Memoization. What else? What else? Istvan wants to know what are some of the IDEs I would recommend. That's a good question. Let me actually answer that right now since we're here. And everyone else who's keep typing in your questions so we can add them to the list. So there are a few IDEs. Well, first of all, you should use whatever IDE you like best. There's not one correct answer here. So don't worry too much about getting it right or wrong. The first IDE that I recommend is actually using Jupyter Notebooks. In some respects, it's a little bit hard, but especially when you are starting out in programming, it's a great way to just move pieces of code around, add your own notes in there. So I always recommend that. A few of the other ones I would recommend for Python specifically are PyCharm. That's one. Another one that people like as well is VS Code, which I believe is from Microsoft. I think my boss uses VS Code. And let's see here. What are some other good ones that I like? The one that I actually use is I use Sublime Text 3, which is very customizable. That's why people like it. So those are some that are good. And of course, I probably need to Atom IDE. There we go. The other one is Atom, which is which is built by GitHub. So those are some options. There's no right answer. I would say about 90% of the coding I do is in Jupyter Notebooks, mostly because I'm preparing that code to be looked at by students. And then that other 10%, I'm writing code probably in Sublime Text. Oh, another one is Spider. Let's see here. IDE Spider with a Y. And if you download the Anaconda distribution, which is what you would need to run to run these notebooks locally, I believe Spider comes with that. So again, another option. These are all good options. Going back to some of the questions that people have, I see that list comprehensions are back, and people are also interested in memory. Let me just scroll up on the answers to make sure that or on the questions to see if there are any that I've missed. I don't think so. Okay, good. What else? What else, guys? What else can I help with today? All right. Well, in the meantime, I'm going to go to Python and I'm going to go to what did I want? What was the notebook I wanted to look at? I wanted to look at algorithms. I see your question, M. I see you're interested in unpacking. Can you give me a little bit more detail about what you mean when you say unpacking? And of course, we have the IP mini project. Okay, so what I want to do is I'm going to open up my algorithms notebook. And I'm going to go down to the memoization section. And before I do anything, I'm going to go cell run all above. And let me open up another notebook here just so I have it available to me on my other screen over here. Okay, beautiful, beautiful, beautiful. So let's talk a little bit about memoization. And the whole idea behind memoization is that the whole idea around memoization is that you can often speed up a process in your programming, not by actually deleting lines of code or combining lines of code, but just by remembering certain calculations that you make so that in the future, if you need to make those calculations again, you don't need to actually do the calculation. You can just look up your previous answer. So it basically saves you by doing an operation. It saves you from doing an operation by just remembering what you did before. Now, the example that we use in our notebooks is we start with our Fibonacci sequence. We're doing a Fibonacci sequence where the next number in this the sequence starts with 0 and 1, and then the next number in the sequence would be the sum of the previous two numbers. So it's 0, 1, 1, 2, 3, 5, eureka. And that's what we have written here, where basically we say, give me a certain number of Fibonacci blah, 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 blah. So, and what we're doing here is we are doing it recursively, right? We calculate the Fibonacci numbers recursively. And so if I do Fibonacci recursive 5, I actually get 5. Let's do it the following way. And what that is doing is it's going here to this last line of code. And what it's doing is it's saying, give me the Fibonacci recursive for 4, and then give me the Fibonacci recursive for 3. And then those particular processes are then going back and then doing it for 2 and 1. And then eventually it hits this ground truth where it is either 0 or 1, and it actually gets an answer. And so then those recursive loops, they build back up again, and we get our final answer. Now, in this notebook, we also do a separate implementation that basically allows us to see the different calculations that we're doing for our Fibonacci numbers. And what we've done here is we've actually printed it out in this cute little pyramid. And I see Oladameji is saying that my screen display is a little bit blurry. If you find that the screen is blurry, the first thing I'll do is I'll make it a little bit bigger just so it's easier to read. But the other thing is you may need to reduce the resolution at which you're streaming these office hours in order to get a clearer picture. So you might have to downgrade the resolution. Okay, so what we can see here is that we start with 5, and in order to get 5, we need to do 4 and 3. And in order to get 4, we need to calculate 3 and 2. In order to get 3, we need to calculate 2 and 1. And we can already see that there's a lot of repetition going in here because we have to calculate 3 here, we have to calculate 3 here as well. And then when we get to 2, we have to calculate 2 here, 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 and then it looks like we need to do, so as we go recursively, there are calculations that we have to do over and over again, right? Calculating the Fibonacci for n equals 2, we do that 3 times, for example. So is everyone with me? Any questions up until now? We've seen how our recursive model tends to repeat calculations. Repeat calculations. Jessica says that they are with me. Thank you, Jessica. Okay. And Abose wants to know, does the repetition mean that it remembers? In this case, with this recursive implementation, it actually doesn't remember. So every time that you see a 2 here, it's recalculating it. So if we could remember previous answers, this would greatly speed up the process. For example, we would only need to do the calculation for 3 once instead of twice. We would actually need to, instead of doing the calculation for 2 3 times, we would only need to do it once. And the same for 1, which it looks like we do 5 times. And the same for 0, which we have to do 3 times. So just add those all up and think of all the steps we would save. In fact, we can do this with a larger example. And we can see that it's even more complicated. And we can see that it's even more complicated. There's even more recalculations that we need to do here. So let's change this. Let's change this a little bit. What I'm going to do is let's use memoization. And what we're going to do is every time we do a calculation, we're going to save it. And before we do a calculation, we're also going to make sure that we haven't done it before. Now, if I want to store something to be able to look it up quickly at a later moment, what is a good Python data structure for that? M has an idea of a list, and Abose has an idea of a dictionary. Well, let's check this out. Let's see which is going to be faster. Let's say that I have a list of Fibonacci numbers. So it's going to be 0, 1, 1, 2, 3, 5. And let's say that I also have a dictionary of Fibonacci numbers, where I know that the 0th number is 0. I know that the first number or the next number is 1. I know that the second number, or at index position 2 is 1. And let's see here, at index position 3 is 3. And then finally, at index position 4 is the number 5. Now I can't use a set here because I do have some repetitions, but let's think about this for a second. Let's think about this. If I want to know, all right, so if I want to know what the fifth Fibonacci number is, oh, sorry guys, sorry, I'm missing the 2. I'm in trouble. I'm in trouble. Data failure, data failure. Danger, danger. So let's say that I want to know what the fifth number, the fifth Fibonacci number. I want to look up the fifth Fibonacci number. Now let's think about this 2 ways. Sorry guys, sorry. Thank you for, all right. If let's talk about lookup in general, okay? If I want to look up a number in a list and I want to say, where is the number 5 in this list? How many possible, how long will it take me? If I want to find the number 5 here, how long would it take me? In terms of number of steps? It could take me up to, Abose is right, it could take me up to 6 iterations because I need to loop through the list and I check the first one. I check the first item in the list and I go, is this 5? No. I go to the next item, is this 5? No. I go to the next item, is this 5? No. And so on and so down the line. So the speed for this is going to be, the lookup speed is going to be big O n. So the maximum amount it's going to take me to look up an item here is going to be the length of the list. In contrast, if I want to look up 5 in this dictionary, the lookup is actually going to be much faster. It's going to be big O 1. Because all I need to do is just put in the key and I get back the value. And so when you need to look things up, when you need to store values and then look them up at a later point, a really good strategy to use is a dictionary. And that's exactly what we're going to do here when we implement a memoization strategy in our Fibonacci function. So what I'm going to do is I'm going to take this Fibonacci function and I'm just going to change it a little bit. I'm going to call this my lookup. I'm going to create a dictionary, and this dictionary is going to have 2 items in it. It's going to have the first 2 items in the Fibonacci list, in the Fibonacci sequence, right? So it's going to have the index, the first item at index 0 is a 0, and the second item, the one that's at index 1, is a 1. And I'm going to receive a number here. I'm going to receive a number. And the first thing that I'm going to do is I'm going to look and see if that number is a key in my dictionary. So the first thing I'll do is if that number is already in my dictionary, I'll just simply return that number. Oh, I see why this is. So I'm actually just going to call this, actually, let's call this lookup. I'm actually going to do it the original way here. Okay. And Abose is right. Here, n is going to be the key value. So I'm going to look this up. I'm going to look up in the dictionary. And if it's in the dictionary, I'll return the value right away. And actually this, I think I can just, well, then I have my original elif statements, if it equals 0 or 1. And then finally, what I'm going to do is, if it's not, I'm going to do the same recursive function that I did before. But what I'm going to do is once I am done, once I find my answer, it's going to store that answer as a new key value pair in my dictionary. So let's take a quick look at this here. I'm going to add a new cell below. Oh, I got an unexpected value. I'm going to put a, there we go. I'm going to put just a backward slash here so that I can split this out along 2 lines. And let's say I look at Fibonacci mem for 5. And I also need to give it that dictionary. There we go. And it gives me my 5 back. So let's see what's happening here. I wonder if I do it this way. I wonder if I remove this. I don't need this, maybe. It still seems to work. Okay, good. So what I'm going to do is the following. Let's put some print statements in here so that we can easily see what's going on. So the first thing is, if it's in my dictionary, I'm going to print n is in lookup. And actually, we can make this a format string. And if not, I'm going to say f is format string, n is not in lookup. So now I'm going to run this again. And what we see is we start with 5. It's not in the lookup. And it cycles through 4, 3, 2. And then all of a sudden, 1 is in the lookup, right? So it's in the dictionary. that calculation doesn't need to be done. And then 0 is in the lookup. That calculation doesn't need to be done. And then 1 is in the lookup because we did it previously. So that's another calculation we don't need to do. And then whereas before 3 and 2 were not in the lookup, because we ran those calculations and stored them in our lookup table, in our lookup dictionary, for the last 2 calculations in this loop, they are there. So basically, all of these calculations are calculations that we didn't need to make. And for that reason, we are saving time through memoization. So questions, 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 questions. Let's add another print statement here. I'm going to print Okay, here we go. This is a little bit easier. So basically what happens is we see things are not in the lookup, but then as we run through, we begin to add them to the lookup. And so that's why we don't need to look up 2, we don't need to look up 3, et cetera, et cetera, et cetera. We can maybe even just put this inside parentheses. There we go. And so what's happening in this algorithm? It goes 5, 4, 3, 2. It doesn't know what those are. So it's working recursively. And then all of a sudden it gets to 1 and it's in the dictionary. So there's no problem. It gets to 0, that's in the dictionary. And because it has 0 and 1, it can then calculate 2. And then because it has 0, 1, and 1, it can then look up 3. And then it gets back to 2, and it's already there because we added it. And that allows it to calculate for 4. And then it looks up 3 again, and it's there because we added it. And that allows us to do the calculation for number 5. So basically, we have a calculation that we need to do. We check to see if it's in our lookup table or our dictionary. If it's already there, we don't need to do it. But if it's not there, then we do the calculation and we store that result back in our dictionary for future use. Let me scroll up to the code again. So in the first if statement, that's where we look up to see if our answer is already in the dictionary. If it's not, then we have to calculate it. So we calculate it here, and once it's calculated as ANS, we then add it to our dictionary. What do you guys think? Clear? Not clear? Should we talk about it more? How are people feeling? Theodore says it's not clear yet. Excellent. Well, let's take a look at it. Abode says it's good, so we're split here. Let me remove these print statements, and let's do some annotation. So, step one is I have my function. I say I want you to give me the fifth number in the Fibonacci sequence. Actually, it's the sixth number in the Fibonacci sequence. And I also pass it a dictionary of the first two numbers in the Fibonacci sequence. And so what I'll do is, the first thing is, I'll check if I'll check if, let's see here. I'll check if n is in my lookup dictionary. If it is, I see people want another example. Let me think of a good example here. Uh, let's do factorials. How about that? I'm doing this a little bit improvisational, so it might take some time. So let's do factorials. Now, for those who do not have not heard the term factorial before, a factorial okay, a factorial is usually written, you have an n and then an exclamation mark after it. And what it means is it is the product of all the positive integers that are less than or equal to n. So for example, if I have n equals 5, 5 factorial is the same as 5 times 4 times 3 times 2 times 1. And that equals, let's see here, 5 times 4 times 3 times 2 times 1 equals 120. Okay, is everyone with me? Good, glad to hear it. Now, I'm going to go back to my notebook here, and I'm actually going to open up I'm going to create a new notebook so we have something fresh to work from. All right. Now, the first thing is, if I wanted to know, just so we're not worried, or not worried. What am I saying? I am speaking incorrectly. Um, Keep in mind that let's see here, factorial. Factorial, we can actually already do it. Import math, and the math. Let's see here. I'll go from math import factorial, and that way, if I want to do this, I can actually do it this way, right? So there's a quick Pythonic way where it's already been implemented. So we have a way to check our answers. Now, let's create a function, and we'll call it not fact mem for factorial memoization. And let's say there's n and our lookup. This isn't a fantastic example, but it's all I got right now, guys. I'm thinking through the algorithm of this, and I'm like, but at any rate, let's just roll with it. Okay, so the first thing that I'm going to do is let's assume I'm going to start with my fact mem, and let's say I want to know 5, and I'm going to start with my lookup dictionary, where I know the 0th number. For example, if I look at let's delete this. If I look at factorial 0, I know that it's 1. And if I look at factorial 1, I know that that's 1 as well. So I'm going to put here 0, 1, and also 1, 1. Now, the first thing I'm going to do is I'm going to check if n is in my lookup dictionary. So I'm going to go if n in lookup, return lookup n. Let's try this out just like it is. I'm going to say, give me the factorial for 0, and I'm actually passing in a dictionary where I know the 0th element is already there. And so I can see that this works, because what's happening is I'm passing in my n, which is 0. I'm passing in my dictionary, which has these two keys in it. The first thing it's doing is it's looking up to see if 0 is in my dictionary. And because it is, it returns the key associated with 0. I'm sorry, it returns the value associated with the 0 key. Is everyone with me? The next thing I'm going to do is if it's not, right? If it's in it, it's fine. And if not, we have some problems. Now, Anupam has a question, which is, are these built-in methods more optimized than the user-defined methods? I would say 9 times out of 10, or 95, 10, or 99 times out of 100, yes. So it's true that if I were programming, I would just use the factorial that already comes in the math library. But this is just for illustrative purposes. All right. And so the next thing I'm going to do is I'm going to say, if it's not in the dictionary, I need you to calculate the answer for me. And in order to calculate the answer for me, I need you to give me n times the factorial for n minus 1, and then we pass in the lookup. So let's take this and let's move it outside. And let's say n equals 2. What I'm going to want to know is what is 2 times 1, or factorial of 1, and factorial of 0. So what is 2 times 1 times 1? I got a name error here. Oh, lookup is not defined. Oh, wait, I need to actually put this dictionary in here. Sorry. There we go. So this calculates the factorial for me. And then what I'll do, so let's see here. If it's not in lookup, calculate answer. And Tope has a great question. Why do we have to pass in the lookup dictionary? Is it because it's part of the formula? Yes, because that lookup dictionary is going to be growing, and we want to be able to pass it, no matter how, as it grows, to the subsequent calls of that function. Great question. And then the next thing I'm going to do is I'm going to say look up answer, or excuse me, look up for n equals answer. So if it's not in the lookup, we're going to want to calculate the answer here, and then store the answer in the lookup dictionary. So now, if I go back and I try to run this function, I'm now going to see if it works. It works for 0. It works for 1. It works for 2. Oh, wait, I actually need to return the answer. Excuse me. It works for 2. It works for 3. It works for 5, and it works for 10. It'll work for anything now. So this would be another example of memoization. Now, Abose has a great question here about memoization. Will memoization take up more memory because we are storing these lookup values for future reference? The answer is yes, it does take up more memory. And generally, when you're thinking about how you're going to build a program, you often have a trade-off between speed and memory. But the good news is that generally speaking, or in the world in which we currently live, memory is cheap. Do you know what I mean? Like my computer has gigabytes of RAM. It's not a problem. And so I choose to optimize speed at a little bit of cost to memory. Other questions, other questions. And so Bose, you're right. The trade-off is ever present. So I hope that second example was helpful. Jessica, Dorcas, I hope that was a good second example. Phew, Jessica says it was better. Whew, good to know. Okay. Well, wow, we only have 7 minutes left. So let's see what other questions we can get done in that short time. I'm going to, oh, let's see here. Ken wants to know, where is the lookup being updated? It's right here, where I'm saying store the answer in the lookup dictionary. Okay, beautiful. Well, with our time left, let me just go back to where we were with we've talked about memoization, we've talked about IDE. List comprehensions, we've spent a lot of time talking about them previously. So I'm going to just refer whoever's question that was to our office hours from last week where we looked at list comprehensions more substantially. And so memory, I can't actually remember what that one was. Sorry. And so let's just move to unpacking with the time that we have left. Okay. So unpacking is this wonderful thing that you can do in Python where you can assign multiple values to multiple variables within one line of code. So for example, let's say that I have a tuple, and that tuple has two numbers in it. It has the number 1 and it has the number 9 in it. So that's a tuple. Now I have a couple options. Let's say I want to assign this tuple to a variable. So I can create a variable name, and I'll call this my tuple, and I'll assign it using the equals sign. And so now, if I type in my tuple, that's the input, and the output I get is that 1,9 tuple that I originally saved. Now, let's say that for whatever reason, I want to be able to access the first item in my tuple. How would I do that? how would I get that first item? How can I just get that 1 or that 9? So Anupam has an idea. I could just put in the index position. So I could use my tuple and then square brackets and 0. That would give me the 1. And if I wanted the 9, I could put in index position 1, and that would give me the 9. Now, that's very nice, but there is a little bit, let's say that I know that I'm always going to need the 2 items that are in this tuple. I'm going to need to assign them to other variables. So for example, let's say I always know that I'm going to have to assign the 1 to var1. And let's say that I always am going to need to assign the 9 to another, oops, not 9, excuse me, this is 1. Now, I could do it this way, but this isn't very Pythonic, right? We have 3 lines of code, and in fact, what we could do is put this in 1 line of code, where I could do var1, comma, var9 equals my tuple. Actually, what I could just do is go var1, var9 like this. And now, if I type in var1, I get a 1. And if I type in var9, I get a 9. Any questions? Any questions about unpacking? And of course, the other thing I can do is, this is a tuple, right? So it's not a problem. But I could also just do it like this. If I had 2 values that I wanted to assign to 2 other values, or 2 values that I wanted to assign to 2 variable names, I could also do it this way. Now, you might not always want to write something in this way, but it's an option. And you can put in as many as you want, but at some point it's going to become hard to read. And one place in where you will find this, is, let's show you guys, let me show you guys an example. Let's say I have a list and it has A, B, C, and D in it. Okay, Topiki has a question. Can we unpack a dictionary? Let's try that. Let's take this list and let's turn it into a dictionary. So let's say we have 0, the key 0 is associated with the value A, the key 1 with the value B, the key 3 with the value C, and the key 4 with the value D. And we'll call this my dict. Let's say that I want to have a for loop. So I could go for, and then something will go here in my dictionary. Now, when you unpack something in a for loop, whether it's a list of tuples or whether it's a dictionary, you can do a couple things. You can assign it to a single variable, But the other thing you can do is you can unpack it right there in the for loop. So I have key and value. And so what's going to happen is it's going to go through my dictionary and it's going to take out the key value pairs and separate them into two different variables, key and value. So I can say print key, and then I can say print value. Oop, I got a cannot an int object. What is this? I know you can. Cannot unpack non-iterable object. What is this? Let me think about this. No, this should be able to. Let me think about this. Hold on. If I do my dictionary, I remember. Excuse me, guys. I want to do it this way. So I'll do my dictionary dot items, and then I'll print X. What is going on here? There we go. Okay, so what's happening is I'm taking out the key and value pairs from my dictionary as a list of tuples. And so I can either work with them as tuples, or I can do key, comma, val, and print them out separately. So for example, I could do key here, and I could do value here. So if you wanted to unpack a dictionary, that's how you might do it. Okay. Well, it looks like we got so excited about looking at all this stuff that we've actually run over a little bit. So I'm going to have to rush off to my next meeting. But if you had any questions from today, please hold on to them so that we can address them tomorrow. And if I didn't have time to address your question today, I promise I will get to you tomorrow. And we are definitely going to look at the mini project. So tune in tomorrow, and then we will just like all answers in the world will be solved. And until we meet again, happy, happy, happy data science. Take care, everyone. See you tomorrow. Bye bye.